Dear friends and students, welcome to Infos. Welcome to oil and gas training session. In this, we are already finished almost 10 part of basic instrumentation and control system. So all of you are watch that video one by one. If you didn't watch, please subscribe this channel and watch all of my 25th 25 videos uploaded in Infos YouTube channel. So you will get some very good idea on oil and gas operation and basic instrumentation. So in this video, in part 10, we are discussing about fire and gas detectors. So this is also a part of important facilities, protective equipments in oil and gas operation. Not only oil and gas, some major industries. So how these fire and gas detectors are working? What are the different type of detectors? What are the basic principle? How it protect the oil and gas facility and operation plant? So we will discuss this all in detail. Welcome to this video. So fire and gas detection and mitigation systems are key to maintaining the overall safety and operation of industries and facilities. A fire and gas safety system continuously monitor, like using a camera or some other system, it's continuously monitor for abnormal situation such as a fire or a combustible or toxic gas release within the plant, and provides early warning and mitigation actions to prevent escalation of the incident and protect the process or environment. Remember that one, all operation plant logic is to protect operation personnel, plant and environment. So all fire and gas systems are working for to protect operational personnel, plant and environment. In case of any abnormal activities like fire, gas leak, toxic gas leak, any various under this type of any type of this situation, to make sure that no hazardous situation is taking place. According to international standard, safety implementation is organized under a series of protection layers which include at the base level plant design, process control system, work procedure, alarm system and mechanical protection system. We are already discussed some of the levels like instrumentation control system. We already discussed that one, like here it is explaining that is process control system. So work procedures we are going to discuss in our future classes, and alarm systems and various monitoring devices connected to shutdown activities that we are going to discuss in this class, that is mainly focus on fire and gas system. So the safety shutdown system is a prevention safety layer which takes automatic and independent action to prevent a hazardous incident from occurring and to protect personnel, plant and equipment against potentially serious harm. So in all these connection systems are connected to safety shutdown system is a prevention safety layer. So it will take automatic and independent action which prevent a hazardous incident from occurring and protect personnel, plant and equipment and environment also against potentially serious harm. Conversely, the fire and gas system is a mitigation safety layer tasked with taking action to reduce the consequences of a hazardous event after it has occurred. Just to review this picture, how it is working. In the left side, it is fire detection is there, like smoke, heat, flame or manual call point, etc. Or gas detection is there, toxic, flammable, acoustic leakage or manual call point. Manual call point means a person can manually activate if he see anything abnormal or hazardous or dangerous situation, he can activate himself manual call point. So, this logic this devices signal coming to logic server or logic solver, fire and gas controller or fire alarm panel system. So, it will go to switchgear MCC and it will develop alarms and alarm limit and alarm display in various locations. So, it will give the action, the result is a notification appliances like beacon and sounders. Then fire suppression system, it is connected to directly automatically to firefighting system, and another connection is safety shutdown system. So, this will give an overall overall idea, overall view, a simplified drawing on how a fire and gas detection system working. Slight variation according to the logic of the various companies, but in general we can say that this way the fire and gas system is working. Let us go for in detail of fire and gas system, fire, smoke and gas detection. The main element that are detected is as follows: heat is there and smoke, light radiation, gas. These are the way we can find out whether it is a gas leak or a smoke formation or light radiation or gas leak or heat generating way in nearby the various equipment. So, different way we can find out. Type of detector using in fall into four main category: heat detectors, smoke detectors, gas sensing fire detectors and flame detectors. So, these are the detectors. We will take one by one whatever the basic how it is working. Let us see and understand. Our type of detector is heat detector, smoke detector, gas sensing fire detector and flame detectors. Let us see the first one, heat detector are the best suited for fire detection in small areas, example office, home places, entertainment and food preparation areas. Offices on some complex have alcohol filled glass ambules that acts as retaining valves. Heat detectors are normally placed on the ceiling area where the heat has raised through the process of convection. This causes the alarm to trigger the process. Look at the system. This is the back view zone area. So, this is the rise of the fixed temperature. This is the instrument which is keeping the ceiling. A heat collector and a fusible solder is there. So, when the heat is increased, so the system will it where the heat rises and the process of convection, it will a diaphragm is there. So, when it is the fuses, a melting fuse is there. When the heat is increased, this melting fuse is melted and it will connect to a sprinkler system or firefighting system that will activate automatically. So, sprinkler systems are combined heat detectors and extinguishing devices. It consists a soft metal bulb which act as a closed valve when no environmental change is present. Upon detection of change, heat will break the bulb which allows water under pressure to flow, and this pressure causes a fine fan like a blade to turn the sprinkler and the water in various directions. They operate on a change in the physical state of a material, example using a metal like lead or tin that will melt at a predetermined temperature by using a thermoelectric detector where a thermocouple or thermopile unit produces an increase in voltage as the temperature increases. These type of detectors may have used in fixed roof storage tank for fire detection. So, one picture schematic representation giving a fire sprinkler system. So, fire happen here, it is a step 1. Where is the step 1? Step 1, it is here, the water tank is there. So, 2 is the water operating pump. then it is going to 3, it is step 3, that is a water flow detector operate, and 4 it is alarm valve operate, step 5 dehydrate delayer operate, then 6, 7. So various steps are here to explain how it is a fire operate in the various conditions. So like 1 to 10, just to review this one and understand how it is operate this one. Step 1, step 2. So this is the spire sprinkler, step 2, and step 3 this is water flow detector operate, and step 4 the alarm valve operate, like that one. So it is giving some idea on how a heat detector connected to a fire sprinkler or fire water sprinkler system. Next is smoke detector. The two primary smoke detector systems are ionization smoke detector, a photoelectric smoke detector. We are not going to deep into this principle of working principle of this one, but smoke detector also, remember that one, smoke detector also like heat detector, another safety devices can connect in various operating area or indoor area where, or food cooking area where there is a plenty of smoke can generate. So to prevent the hazardous condition or big fire happen, so smoke detectors can work and mitigate the fire hazard in that area. So ionization detectors have a small amount of radioactive material that ionizes in the air in the sensing chamber. When smoke particles enter to the ionization area, they lower the conductance of the air, and at a set level the detector will alarm. So this way the schematic representation, look at that one, we will get some idea on this one. The left side picture is giving a normal condition, what is there, no alarm is there, electrical power source and changed particles, radio isotope, positive and electrode, current detector. So in this one there is a clear normal condition, there is no smoke or something is enter to this chamber, and it is not disturbing the this path. So in this one have a look, that one it is smoke is there, inside, and it will negative electrode, positive electrode and radio isotope, current detector. So electrical power source that will ionize this and create an alarm. This way the smoke detector is working. So ionization smoke alarm. So this is another picture, and it is a battery operated one. Alpha particles knock electrons free from the air molecules, which then flow to the positive plate, creating a small current in this one, and smoke particle enter to the chamber and attach to the ions, rendering then neutral, disrupting the flow of current, thus indicating the alarm. Photoelectric smoke detectors detect the presence of suspended smoke particles in the air, either by changing the light intensity over a beam path or by scattering a light beam. Most homes now have smoke detectors fitted in the kitchen area and the area between the kitchen and the stairs. In accordance with the building regulation, all homes in the United Kingdom must be fitted with 2 smoke detectors as a minimum. They are also readily available in most electrical stores. This is another picture of a smoke detector. Photoelectric principle is using working on this one. Another one is a gas sensing detector. This is widely using in operating plant like oil and gas. If you have any chance to visit your plant, just to look at that one, where is your gas sensing detectors are located and how the working principle, understand the working principle of that. A gas detector measures and indicates the concentration of certain gases in the air. Changes in the gas content of the environment causes the gas detector to operate an alarm. typically employed to prevent toxic exposure and fire. Gas detector are open battery type operated devices used for safety purposes. As detectors measure a specific gas concentration, the sensor response serves as the reference point of scale. Means now there is no gas leak, means it will read as 0% level of hydrocarbon leak. When the leak start like 1% in air or 2% in air or 0.5% in air. So the set level we can calibrate on the sensor and create an alarm. When the sensor response surpasses a certain preset level, an alarm will activate to warn the user, or it can create a automatic shutdown activities. One or two principles are used in gas sensing detection, which are detailed below: semiconductor or catalytic element. I told you that we are not going to the working principle or the manufacturing technology, how it is done. Instead of that, we are going to understand the working principle, how it is operating in different type of conditions. So mainly the gas sensor is working on the methane hydrocarbon percentage in air. If just to review this picture and understand that one is methane is a hydrocarbon, first element in a hydrocarbon family, CH4. In CH4 is methane leak is in the air. If it is coming a particular level of leak, say 5% leak in air, it can ready for an explosion or fire. That is called a lower explosive limit, LEL. Up to 5% of leak in air, methane could not create a fire or a combustion mixture. It will not form a combustion mixture. So methane and air forming a combustion mixture at the percentage of 5. 5 is the LEL. That means 5% of methane presence in air, that is 5% air and 5% methane is there, mean it is ready to fire. Up to what level it can go? Up to 15%. If the 15% of methane percentage is available in air, of 15% methane and 85% air, that can also create up to that point it can create a combustion mixture and ready for the combustion. That is called upper explosive limit. Above this upper explosive limit or below this lower explosive limit, it is combustion is not occurring because of below LEL it is less fuel or weak fuel condition, and upper explosive limit is weak air condition. So in these conditions fire will not happen below LEL and above UEL or HEL, sometimes got a higher explosive limit. So in between this limit always a hazardous situation can form, and if the leak is in this condition or methane is present in this condition, a fire can happen anytime, a source of heat or a fire triangle forming. So 5 to 15 is the range of methane. Some propane, acetylene and ethylene, hydrogen, it is given that one, but mainly the gas detector is working on this methane LEL percentage in air. So we have developed an example here, LEL 5% in air. LEL is 5% in air. That means if 5% leak coming in air, it is 100% leak, it is considered as 100% leak and ready for the fire. So the gas detector calibrated as 5% gas leak is 100% reading. That means it is ready to fire and it is very hazardous situation. So should not reach that level. So the alarm and any mitigation action need to take well below 5% leak or 100% reading, of the gas sensor. So, how it is working, let us see from this example. And a low level alarm a low level alarm is set at 20% of 5% gas in air. That means how that 20% is calculated? 5, that is LEL, into 20% is 20 by 100, that is 1. That means 1% methane exposure coming into air, 1% gas leak. That is a much safer level of LEL. So, that time when 1% gas leak present in air, the detector sense and it make a low level alarm, which is safe condition to take a proper action. So, low level alarm is a annunciating and only making sound and alarming the operators and other personnel to take proper action. It will not take automatic shutdown or any mitigation action immediately. So, still when the gas leak exceeds and reach 40%, like various companies operate this in different logic. Instead of 10% they will operate instead of 20% they will operate 10%, or instead of 40% they will operate 30% leak. We can calibrate according to that logic. So, but the logic is like that one. When the gas leak exceeds and reach around 40%, which means 5 into 40 by 100, that is around 2%. So, when the 2% leak, I told you that one LEL is 5%, that is the very hazardous situation, but 2% leak is compared to that one. Look at to this figure, 2% is here. It is very safer situation. So, when the gas leak 2% leak gas in air, the sensor detector and make a high level alarm and followed by activate shutdown system and the corresponding downstream or corresponding shutdown systems and activate trip systems according to the designed logic to that particular company. So, this is the way the gas detector is working. If you have getting a chance or opportunity to visit a gas sensor, please visit there and understand the working principle and how it is working, various gas sensing, which gas is sensing, and how understand the working principle of a gas sensor in your plant. Next is a flame detector. A flame detector responds to the radiant energy from a fire. So, both infrared and ultraviolet detectors are used in the process of detection. With these detectors, it is important to ensure that they are not blocked by object placed in front of the example scaffolding, as they need to be able to see the fire to respond. This is a simple pictorial representation how a flame detector working. See the flame area and the detector ABC, sensor A, sensor B, sensor C, that is a signal, and the signal analysis using the various logic like fuzzy logic and wavelet and decision process. It will conclude that one whether it is a fire. So, whatever the fire in that area in the range it is coming, so it is considered as a subsequent action like alarms or shutdown activities. So, these are the two instruments using for connecting in the field for flame detectors. So, fire detection is some critical areas of the plant cannot be manned by day and night. If a fire occurred in one of these areas, the equipment could be badly damaged before a fire was discovered. So, in these areas fire detectors are installed. So, these are optical devices which detect the ultraviolet and infrared part of the spectrum or light band. Each of the detectors in-housed in an explosion-proof housing fitted with a glass viewing window. It is important that these windows are kept clean at all time because the dirt and dust can reduce the amount of UV and IR reaching the sensors. These windows must only be cleaned following the manufacturer's procedures using the recommended materials. Any violation of these procedures would invalidate the classification of enclosure. The system is fully automated, performing self-checks for all its circuits once every minute. If a fault is detected, a light will illuminate in the control room. If and when this happens, the instrumentation maintenance department must be informed so that the fault is rectified immediately. The UV protocol devices measure the intensity of UV light seen in its area of view. Usually more than one detector is used to monitor in an area with the area of view designed so that the detector view is overlapped, giving full coverage of the whole area. The whole system uses voting logic. Voting logic means it is not keeping only one sensor. It will take 2 out of 3. It's like 3 sensors are there. At least 2 sensors are giving the proper reading. It will consider as a real reading. That is the voting logic. To prevent the false alarms, for example, if 2 out of 3 register high UV light levels, this could trigger a fire alarm. If any 3 detect UV, then shutdown process of the plant is initiated and fire extinguishing components are released. The IR sensor also work in a similar principle, but sense the heat in that viewing area. See the difference between UV and IR. IR is infrared and UV is the ultraviolet. So, the hotter an object is, the more IR emissions are radiated. Once again, the voting logic system is used as in the UV sensor. So, thanks for watching for the basic understanding of the fire and gas detection system. Please subscribe this channel for timely updation and information. Please join our Telegram channel Infos.by HAMSA V BAVA for various updates. So, definitely we will come with another process safeguarding devices in basic instrumentation section of oil and gas training. We are coming, we will update our new video soon. By then, goodbye. Thank you.